When converting a 3-wire delta feeder to a 4-wire Y system, the National Electrical Code, or NEC, provides specific requirements regarding the installation of conductors, including the grounded neutral conductor. The code prohibits installing the neutral conductor strapped to the outside of the conduit. This prohibition is based on several important electrical engineering principles and safety considerations. The primary reason for this requirement is to maintain the integrity of the conduit system as an effective ground fault current path. When all conductors of a circuit, including the neutral, are installed within the same conduit, the metallic conduit itself becomes part of the grounding system. In the event of a ground fault, where a live conductor comes into contact with the grounded metal enclosure, the fault current needs to have a low impedance path back to the source. This low impedance path facilitates the quick operation of overcurrent protective devices, such as circuit breakers or fuses, to clear the fault rapidly and safely. If the neutral conductor is run outside the conduit, this disrupts the intended ground fault current path. The impedance of a conductor run separately from its associated circuit conductors is significantly higher than if it were enclosed within the same metallic conduit or raceway. This higher impedance can impede the flow of fault current, delaying the operation of overcurrent protection. This delay can lead to elevated touch potentials in the equipment enclosure, posing a shock hazard to personnel. Furthermore, the increased impedance can result in higher fault current magnitudes, potentially causing damage to equipment and increasing the risk of fire. Another critical consideration is electromagnetic interference, or EMI. When conductors carrying alternating current are run together, the magnetic fields they produce tend to cancel each other out within the conduit. This cancellation effect minimizes the amount of electromagnetic radiation emitted from the conduit, reducing the potential for interference with nearby electronic equipment. However, if the neutral conductor is separated from the other circuit conductors, this magnetic field cancellation is significantly reduced. The resulting increase in electromagnetic radiation can interfere with sensitive electronic devices, causing them to malfunction or operate erratically. For example, sensitive control systems, communication equipment, and medical devices can be adversely affected by electromagnetic interference. The NEC addresses these concerns by requiring all circuit conductors, including the neutral, to be installed together in the same raceway, cable, or enclosure. This requirement ensures that the ground fault current path is maintained, electromagnetic interference is minimized, and the overall safety and reliability of the electrical system is enhanced. Specifically, NEC Section 300.3 in the 2005 edition and Section 300.3C2 in the 2002 edition address this requirement. These sections mandate that all conductors of the same circuit, including the neutral and equipment grounding conductor, be installed in the same raceway or cable. The term raceway encompasses various types of enclosures, including conduit, tubing, and other approved channels designed for holding wires or cables. By requiring all conductors to be run together, the NEC ensures that the benefits of magnetic field cancellation and low impedance ground fault current paths are realized. It's important to note that the NEC provides some exceptions to this general rule, but these exceptions are limited and typically involve specific circumstances where alternative methods are permitted under strict conditions. For instance, certain types of parallel conductor installations or installations involving intrinsically safe circuits may be subject to different requirements. However, in the vast majority of cases, the general rule of keeping all circuit conductors together in the same raceway applies. In addition to the specific code sections mentioned, other NEC articles provide further guidance on conductor installation and grounding requirements. Article 250, for example, covers the general requirements for grounding and bonding, emphasizing the importance of establishing a low impedance ground fault current path. Article 300 provides general wiring methods and requirements, including rules on conduit fill, conductor bending radius, and support. When converting a 3-wire delta system to a 4-wire Y system, it's crucial to ensure that the new neutral conductor is properly sized and installed in accordance with the NEC. The neutral conductor must be capable of carrying the maximum unbalanced load that is likely to occur on the system. In many cases, the neutral conductor will need to be the same size as the phase conductors. It's also important to ensure that the neutral conductor is properly bonded to the grounding electrode system at the service entrance or separately derived system location. This bonding provides a direct connection to earth, further enhancing the safety and effectiveness of the grounding system. When retrofitting an existing electrical system, it's sometimes challenging to comply with all of the current NEC requirements. In situations where it is physically impossible to install the neutral conductor inside the existing conduit, alternative solutions may need to be considered. However, any such alternative solutions must be carefully evaluated and approved by the authority having jurisdiction, or OJ. The AHA is the local electrical inspector or other designated official responsible for enforcing the NEC. The AHA has the authority to grant exceptions to the code in certain circumstances, but only if they are satisfied that the proposed alternative provides an equivalent level of safety. In some cases, it may be necessary to install a new, larger conduit to accommodate the additional neutral conductor. This can be a costly and time-consuming undertaking, but it may be the only way to fully comply with the NEC and ensure the safety of the electrical system. Another option to consider is the use of a ground fault protection system. A ground fault protection system is designed to detect ground faults and automatically to energize the affected circuit. This can help to mitigate the risks associated with running a neutral conductor outside the conduit. However, ground fault protection systems are not a substitute for proper grounding and bonding, and they should only be used in conjunction with a properly installed grounding system. Furthermore, in industrial settings, it is essential to also comply with relevant industry standards and best practices for electrical safety. Organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA, publish standards and guides that provide additional guidance on electrical system design, installation, and maintenance. These standards often go beyond the minimum requirements of the NEC and incorporate industry-specific best practices. When working on electrical systems, it's always important to follow safe work practices. This includes energizing circuits before working on them, using appropriate personal protective equipment, or PPE, such as gloves and eye protection, and following lockout/tagout procedures to prevent accidental re-energization. Qualified electrical workers should be trained and competent in the safe work practices. Failure to follow safe work practices can result in serious injury or death. In summary, the NEC prohibits running a neutral conductor outside of the conduit for a variety of reasons, including maintaining the integrity of the ground fault current path, minimizing electromagnetic interference, and ensuring the overall safety and reliability of the electrical system. When converting a 3-wire delta system to a 4-wire Y system, it's crucial to comply with the NEC requirements for conductor installation and grounding. If it's not possible to install the neutral conductor inside the existing conduit, alternative solutions may need to be considered, but any such solutions must be carefully evaluated and approved by the authority having jurisdiction. Always follow safe work practices and consult with qualified electrical professionals when working on electrical systems. The NEC is a comprehensive document that is constantly evolving to reflect advancements in technology and changes in industry practices. It's essential to stay up to date on the latest edition of the NEC and any applicable local amendments. The NEC is not intended to be a substitute for sound engineering judgment, and it's always advisable to consult with a qualified electrical engineer when designing or modifying electrical systems. The information provided here is for general educational purposes only and should not be considered as a substitute for professional electrical engineering advice. Electrical systems can be dangerous, and it's important to work with qualified professionals who have the knowledge and experience to ensure that the work is done safely and in accordance with all applicable codes and regulations. Finally, remember that electrical codes and regulations are in place to protect people and property from the hazards of electricity. By complying with these codes and regulations, we can help to ensure that electrical systems are safe and reliable.